I would like to thank for this invitation. I'm not expert in consciousness study, so thank you very much to Jose, who believe in that my wish to study someday the neural basis of the consciousness will be enough to present some data about what happened with the origin of the consciousness in human being. So also I want to congratulate you because you are extremely young, and I think it's very good news that there are a lot of people studying the mind of the infant and the mind of the human being from this approach, from the neuroscientific approach in Chile. Because when I was young, there were only 2 or 3 laboratories, and we never had the opportunity to meet together and to do something as a network. So congratulations for this network. You are the hope for Chilean neuroscience. So my point is my theme today, the issue that I want to present is the origin of the consciousness in human infant, and there are many questions about that. For instance, first we have to agree that we don't have a clear definition of what is consciousness. I think it's not even for adults. So it's very difficult to try to test if in infant brain or in infant mind exists this phenomena. So the nature of the consciousness, do you see this from far? Yeah? The pointer? You see? No. Well, the first point, the nature of the phenomena is very difficult to operationalize, to measure, in the sense that we will explore a cognitive event that represents a mental event that's not very clear how this, particularly this interface happened. So this is one of the points difficult to understand. But there are many studies, particularly done for other people, not for me, specifically for our team, that are studying and agree that the consciousness, the human being has some element that can be understood as consciousness. So consciousness could be present in very, very early step, very early moment of the ontogenia. So I would like to show you some of this data. Okay, we will start in this case. First, I think one of the challenges of the cognitive neuroscience, the modern cognitive neuroscience, is to try to find a sort of model like this one that is proposed for adults, and hopefully not only represent the cognitive aspect. For instance, here we have I think you know better than me what is global workspace is one hypothesis, one possible hypothesis, that how the consciousness is supported in this integration in the sort of global workspace. And you have several input here. For instance, the long term, you have attentional system and perceptual system that all together converge in this work, integrate in this global workspace, and we want to have something similar in infancy. And moreover, we want to also, if you watch to the other side, we want to also identify the neural basis of this global workspace in processes that can be conscious or preconscious or subliminal, we can say unconscious in the baby. So this is our hope, and I will show you some data that can be useful to propose a model about consciousness during early infancy. So first, I would like to show you that we don't have a lot of study about the brain, the consciousness and the brain in infant. We don't have really. There are very, very few, and I will show you some of them. But we can say that newborn, from the very early step of the ontogenia, the newborn is the baby who is just born, exhibit in the behavioral some criteria that we can say that is possibly indicate that they're conscious of something, they're conscious of what has happened to them or what has happened in their own life, in their inner life. So for instance, they are aware about the body. I'll show you some experience about that, about the self, and about the world. So for instance, another point that I will show you, I will tell you before I show you the experiment itself, is that when we say the infant has consciousness, we say, okay, the infant knows a lot of things. Knows a lot about what? About self, about the body, about what happened in the others, about what happened in the mind of the other person. So this can be a sort of evidence or piece of evidence to think that the baby is having a conscious thinking. And moreover, there are another series of experiments that show that this way that the infant is processing what happened in the body or in the other minds can be modulated by the experience. So in this sense, all the theory about expectation, about top-down expectation and abstract representation of the phenomena or the multimodal representation of the phenomena, that is also proven in very, very young infants. So the human infant is from very early life can do not only generate some sort of representation of the body or the other person, but also can manipulate this information in a Bayesian model, if you want, can manipulate this information and modify the behavior after the exposition. So I will try to show you this with more specific evidence. So first, we want to say that in order to, one of the proposals that Lagercraft say here is that you need, in order to do everything of this, in order to be conscious, you need a brain. So, and the brain should have enough property to be able to process the phenomena that you are studying. So, for instance, in this case, the brain of the infant should be anatomically and functionally ready to process the information and generate the consciousness in the different type of consciousness that you can use. So first we can say the neural setup is ready from very early in life. For instance, we can ask for if an immature brain can be conscious. Well, if we study the anatomically, structurally speaking, the embryology of the brain of the baby, we can say that there are many variations from 25, from all the gestation, but from the 25 weeks of gestational age, the brain of the baby is ready to, anatomically ready, is prepared to analyze any type of stimulus that can be consciously processed. Okay, so this is one of the presentations. I don't know if you see here, but before this period, we can say that it's not clear. At least the people who work on this agree that before the viability, you say, what they say, viability, the viability of the human fetus is, I think, is the origin for the moment. The origin of the consciousness, we can say, if the fetus is has viability, from this moment you can have structurally and functionally, the brain is ready to generate a phenomena that can be understood like consciousness. Okay? So before that, at least in the modern time, we'd say no. Maybe in the future, when we have the artificial uterus or something like that, we can discuss what happened before, at 20 weeks, for instance. So, in this sense, we can say that can immature be conscious? Anatomically, yes. From when? From 25 weeks, 24 weeks, and in Italy, for instance, 22 weeks of gestational age, because at this they define that from 22 is the moment when the fetus is able to survive by itself. So functionally now, what happened with the function? Is the immature brain functionally trained? Indeed, yes, because we have this spontaneous activity that is regular for different in different part of the cortical, the cortex. Here we see 3 examples, from the 25 here and from left to the right. We have a specific feature that appears, and they are spontaneously training the brain to do something that is related with the processing later. So we can find, for instance, the frontal chart, delta brush, and frontal transient that are typically the spontaneous activity that appears with no stimulus, appears in the preterms. Eventually, we don't have evidence, but we can think that we can extrapolate this to the fetus, so not only the baby when it's born, but also the baby when it's in the womb. They would have also this activity in the brain, the electrical activity in the brain, that the role of this activity would be, this spontaneous activity could be, in some of the hypotheses, to train, to prepare the different part of the cortex to be ready to process a specific stimulus that will be relevant for a particular task. For instance, in the case of the speech, that is what I can tell you more, but in the case of speech, you have that in temporal area, you have this spontaneous activity that is very strong at theta band. It's a theta band that is, you look this burst of activity of the theta and then stop and then appears again, specifically in every preterm infant. And it could be, you can observe this from 30 weeks of gestational age in the preterm babies, but you can also see before in subcortical structure evaluated in animal models. So this could be a possibility that the brain is not only anatomically prepared to generate evidence or work in the sense that you can explain that it is generating a phenomena, conscious phenomena, and also it is functionally trained. So the brain, immature brain from 25, 24 weeks gestational age can be conscious. So another evidence of that is that, what would be the basic requirement to have consciousness? We have anatomically, we know that after 24 we have this connectivity. However, is the connectivity, we need a sort of a specific connectivity be ready to. For instance, we need that the thalamus connected in a sort of amount, the connectivity between the thalamus and the cortex should be huge enough to allow that the consciousness appears. And this will happen roughly about the 30 weeks or 25 weeks from in the fetus. So another evidence is that we found in 40 weeks, this is a neonate, but it's not really a neonate. It's a preterm who was evaluated at the term age, when at 40 weeks, at the 9 months of pregnancy. And in these babies, this is a study done by using a functional MRI, and you can find that the baby has if you want, they're sleeping most of the time, but they're not exactly sleeping in the same resting state. The resting state, they have a sort of switching between different type of resting state. If you want, you can see here that you find in the right part of the slide, you have the primary visual here, then somatosensual motor network, then temporal auditory network, parietal network, and medial and lateral prefrontal cortex network. So the baby, the infant, when you test it in resting state, he is, if you want, switching between these states that can be understood like sort of resting state, but it's not, it's very fast, if you want. The baby don't maintain the resting state, the particular resting state, for a long time. So they need to switch with this, that it's also understood like a training to further, to train in the circuit that will be responsible of the further analysis of the stimulus who they will receive when they are awake. So until now it's clear. Yeah. So another, well, what is the property that Lagercraft proposed? Now they say his state with Changeau, they proposed that the neonate can be conscious from very, very early age. So I will show you some evidence about that. The first one is the fetus. If we understand that the emergence of the consciousness of the mind can be accepted, defined in the human viability, we say that there's some cognitive evidence about that. For instance, wakefulness and awareness. What happened with the baby? In the fetus, when the baby is in the womb, when the fetus is in the womb, the infant, the fetus, is almost sleeping all the time. And it's not really sleeping, it's in a sort of depression. For instance, they have a few oxygen concentration because the mother uses a sort of amount of oxygen, so they receive not the, they say that the fetus in the womb is likely to be in the Everest. Everest? See, Everest? Everest. Well, the fetus is in the Everest, yeah. So they receive not a lot of oxygen, and moreover, he is under the effect of several biochemical substance that produces the placenta, and the placenta makes the baby to be sedated. So they have sedated, and they have not a lot of oxygen. So basically, they are not exactly awake. So we can say if the fetus is not awake, even if they have 38 gestational age, the fetus, we can accept that it's not conscious. Okay? This is a possibility. So what happens when the fetus is born? When the fetus is born, there is a huge explosion, burst, explosion, or liberation of this is a very traumatic fact, even to the birth. So they have to go out from the womb, and there is enormous liberation of the norepinephrine that really produce a sort of activation that is very clear. I don't know how many of you have babies, infant. Lucia, who is just here, when the baby is born, we say, "Oh, my baby," and the baby usually is awake. So it's really with the open eyes and looks like that. There is this explosion, this sudden increment in the noradrenergic system that can generate this special state of wakefulness that allow you to interact with your baby in a social or survival interaction with the caregivers. So we know that this is something that we can observe. What happens when the baby is born before, when there's a preterm? When the preterm also have this increment in the noradrenergic system, but the response is very, very less intense. However, you can see that from when the baby is in the neonatological unit, for instance, you can see that from time to time they open the eyes like that, And not necessarily they are exactly awake, but we can say that the consciousness is limited in a fetus. It's very practically, we can say that it's absent in a fetus, but it's very limited in a preterm babies. So the humans are really prepared to be born at 40 weeks when they are mature. So then in this case, we can observe more conscious evidence about we can expect that the baby can have, the infant can have processes, mental processes that are consistent with consciousness. So there are another evidence, for instance, that say that the baby has awareness of somatosensory stimulus. For instance, they react to pain and they express discomfort when they have, for instance, the venipuncture, when we have to remove blood from the vein and you have this small pain. You have in the brain of the baby, you can react in different way if you have this small pain. So the awareness of, if they react to pain, we can say that they are aware of the pain that they are feeling. This is very early in preterms. But we also have another type of evidence that involve awareness. For instance, the newborn is also aware, can identify different type of smell, and they can react in a different way to good or familiar odors and unfamiliar odors. So we can say that they have a sort of memory about the odor. For instance, the amniotic liquid and also some odors related with what the mother ate when she was pregnant. Some garlic, for instance. Yeah, the garlic, if the mother would like the garlic, have a lot of garlic in the blood, this is some of the odor that can arrive to the fetus in the womb, and they can recognize this odor and memorize and expect that save this memory and use this information to react to different odor later in life. The same happens with the face, the vision and face recognition. The baby are even if they are very myopic, they really don't see, their visual acuity is very poor in the newborn until 3 months, very, very poor. They recognize easily anything that look like a face and prefer anything that looks like a face. Also for preterm, when this brief moment when they open the eyes, they say, oh, I prefer the face to the non-face schema. So they have this attraction that could be innate, if you want, to identify what is the stimulus that are conspecific, and they have a special awareness of this face, this stimulus, like face stimulus, and they can process it consciously. Also, they can imitate. They can imitate not only the face, they can also imitate some movement from body movement. So what is important in the face? In the face is important, basically, many things, of course, but is particularly relevant or salient, the gaze following and vocalization, the face, the eyes and the mouth. So we have done some study we have done and other people also, and we have demonstrated that the infant from very early life, from preterms, they are sensitive to the gaze and they can follow the gaze before what is expected. The gaze following is very mature in the full-term babies, is mature near 7 months old. When you are born 3 months before, you are 3 extra months. Even if you don't open the eyes all the time, from time to time you open the eyes, your mother is here, and the mother do this, do that. So what we observe is that this 3 months accelerates the time that your biological program is waiting that you can do gaze following. So the preterm gauge the follow-up of the other people 3 months before as expected, as compared with the full term. So it's something that is sensitive. The social cognition, if the gaze following play a crucial role in social cognition, the social cognition is a little bit accelerated in preterm. And what is this for? Maybe because if you have a good social cognition, you can also do a hypothesis about what happened with the other. This can help you to understand the belief of the other, or the notion that there are other people with other minds and other thinking, and I can train this knowledge in order to know what happened with the other people. So the other study is also done here because, Cascade and other people, so that when preterm trained, a good thing in the social cognition in the very young babies is that can be trained. It's not only that it's accelerated, but also can be improved from very, very young babies. For instance, if you have a preterm and you interact with him face-to-face, the baby accelerates what are you trying to teach. For instance, they accelerate the vocalization. If you have a group of preterm where the mother just put it like here and food and speak not too much, this baby don't speak, but if you are face-to-face and you say the baby boo, ba, da, brr, blah, 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 etc., the baby start to vocalize also earlier. So it could be accelerated or improved with the experience. So another thing is that they're also aware about auditory stimulation. And when I say auditory stimulation, the main study, the most, the amount, the big amount of the study, have studied speech as auditory stimulus. So what is the awareness about the speech? The awareness about the speech, there are a lot, but I can tell you that the baby, for instance, in the fetus, when the mother repeated some sort of story to the baby in the womb, when the fetus is born and the baby in the period of newborn, they can recognize what the voice of the mother, and they can recognize also the stories that they hear when they were in the womb. So they have the capacity to, they are not exactly unconsciousness, maybe, but they are also, they have the capacity to perceive the stimulation, to memorize the stimulation, and to use this later to make expectation and to detect what is not expected for them, like unfamiliar stimulus or novel stimulus. So they also have the preterm, have the possibility to, not everything is accelerated in the preterm babies. The preterm babies can have expectation about phoneme, the native phoneme, for instance, but you need to, if you want, you can habituate a very young baby to a same phoneme. I think I arrived late today, so I didn't hear exactly all the talk from Lucia, but in some moment she said, we presented a sort of habituation to a phoneme, for instance, ba, 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 no? And then you have ba, 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 ga, like a bottom-up violation of your expectation. So the capacity to ba, 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 to be habituated to this is a complex, if you want, function that require working memory and in some sort of, in some way need the ability to make expectation, to be waiting for the same, for a particular pattern of a stimulus. So this, we can say that the habituation to ba, 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 or to whatever stimulus you say, is an ability that involves not only a reactive response, but it's also an active response, in the sense that is based in the capacity of the human mind to be an expectation, expected for something based on the prior knowledge. So this ability, the habituation, is presented, is already evidenced from the preterm at 25, 27 week of gestational age. So the very, very young babies can detect the ba-ba-ba, ga, when we change in a bottom-up violation of the expectation, but also it's also possible to find the top-down violation. For instance, the study that it's not yet published, but it's a study that we have done with Gislaine and in France, and we have in Chile, show that from 27 weeks of gestational age, we do, if you have ba, 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 etc., many times ba, 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 then you say ba, 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 and you lose the last one, you say, but where is my ba? And this ba, this absence of a stimulus also generates a response of mismatch, showing you that from very early step of the maturation of the brain is already able not only to habituate, but also to do expectation and also to detect violation of this expectation that can tell you a little bit something about the conscious, I don't want to say conscious, I think I have a shame to say conscious, but a sort of precursor of the conscious thinking in the human being. Something that this is really important, that when we do this experiment in babies, when we do linguistic study about expectation in babies, we are not talking about acoustic property. We are talking about something that is very abstract, is that the phonemic property. If I say ba, and Carlos say ba, ba, it's acoustically very different, but it's ba. For the human, especially, this is one phoneme. So what the baby is doing expectation about something that is not physically. It's not the physical property that they are coding, but they are coding and processing some representations that are more than physical. If you want, symbolic, okay? So another example is that they have self-awareness. The self-awareness, I will use just two examples. There are many others about everything that I have said. But one of them is the cry, for instance. The baby can react in a different way when they hear their own cry or when they hear the cry of other infants. So when they are really disturbed with the cry of other babies. If the babies cry, they start to cry soon. However, if they hear their own cry, they can stay for a minute. And they say, well, I'm crying, so what more can I do? Yeah. So the other is the body somatosensory representation of the body. This is a recent study from Medloff in Washington University, and they show that at least the hand, they are very representative in the body. The baby activate the different, how can I tell you, the somatosensorial you touch here, and you have an activation in the contrary cortex, and they react in a different way when they detect that they are being touching themselves or when it's the other person who is being touching. For instance, the mother. If you have the baby and the mother here, and you touch the baby here, and the baby react and have some activation. But when the mother is touched, that is just the hand just behind of the hand of the baby, their reaction is very different in terms of the perception, if you want, and in representation, the abstract representation of this perception of the somatosensorial stimuli. So another thing that is possible, that is not very proven, there are not many studies replicating this study, but it's very interesting that they have an internal perspective. They are able to know, to think about something that is not in the mind. For instance, they can recognize something that open the basis that is not seen. For instance, they can recognize something with the tongue, with the sensitivity that they have on the tongue. So there are many evidence that they have abilities to complex ability that can serve as the basic or precursors, if you want, or the minimal requirement to have a consciousness thinking from very early age in the life. So one aspect that this is very important is the social adaptation. I mean, the infant maybe have some innate, is born with some innate background that allow them to do everything that I have tell you previously. But also they have the capacity to modulate what they learn about this process, this event from the experience. And this experience is socially modulated. The social interaction is extremely important to many things and to change the way that the infant perceive what happened in the world. So we say that the infant they have anatomically, apparently functionally, apparently cognitively, there are some expression of consciousness that we can explore, so how we can measure. And there are not many ways to measure the consciousness in an individual no, that is not able to provide any explicit answer. So there are some studies have taken this approach. For instance, in order to study the perceptual threshold, what is the minimal threshold to be aware of something? There are a recent study from Cuder in France, and maybe I have to explain this, but this is a study where you have a mass, then you have in the central part you have a phase, then you have another mass later, but the crucial thing is that the duration of the phase, we know that the phase is very salient for an infant, so the duration of the phase go from subliminal to supraliminal stimulation. So based on the adult threshold. So you can go from 17 milliseconds to 300 milliseconds. It can stay 300 milliseconds, so in 300 milliseconds you see the phase, and in 17 you don't see ups here. Yeah, and you have different response. You have different response in the if you want that if you are looking for phase or looking for control. If you compare this part of the down map, right, skull map, no sé cómo se. When you have a phase, you have the response when the stimulus is depending on the duration of the stimulation. You can have, when it's supraliminal, you have this response that is the early positive negativity. Then you have the response to the stimulus, the B400, and then you have this late response. The late response is related with awareness. Okay, this is for an adult. This is an adult when you do phases, when you do something that is not phase, and this is the difference. So we expect this difference here, especially for the late slow wave that is very late. It's not just the recognition of there is a stimulus, but this is what this stimulus means. And in baby happens the following. You have, so this is to say that this an early response is perceptually driven, and this is related with awareness. So we found that, so the study found that in the older infant, in the we can say very early in life, from 12 months old, the shape of this response is very similar to this one. You have all the early response, but you also have the late response, okay? So we can say that there really, something happened between 5 months and 12 months. That is a lot of months if you want for baby, but it's nothing compared with the rest of the life of the people, yeah? In a very few periods of the life, they can reach the same sensitivity, the same threshold, the perceptual threshold of the adults in order to perceive something in a subliminal way or in a supraliminal way. So this, anatomically, we can say that the brain of the baby is ready for that. Estoy atrasada, I'm late. How much time?
You have like 50 more minutes.
¿Cuánto?
15
15, yeah. So another is I will just show you maybe two slides more. One is related with top-down expectation. I already told you that the top-down expectation they have been observed in a very young preterm infant. So they react with the violation of the expectation more than the violation to the physical changes in the stimulus. And this has been also proven in this study that this is for 3 months old. The left one is for 3 months old, and in this case, you habituate, for instance, to the change, to habituate to the infant to something that is changing. Ba-ba-ba-ga, 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 ba-ba-ba-ga. After that, you say ba-ba-ba-ga. I expected ga, no, nothing else. So if I don't change, I go to ba-ba-ba-ba, you say, okay, this is exactly the same, but it's not what I expected. So it's not physically driven, and you also have the response. And in both cases, you have in this inferior part of the response, you can have, here you have a red line and a green line, and the red line is for when the change is in the global. In the global mean in the structure of the force. So if you were habituated to a change, if you have non-change, you react. And in the local, that means what it happened inside of this pattern. For instance, you expect no change, and suddenly you change, okay? So the both response to what is physically driven or mentally driven, if you want, in both cases, the brain reacts in the same way. This is another example of top-down expectation. In this case, this study is done in 7 months old with NIRS, with optical topography that is very similar to functional MRI. And in this case, you have this, you present a stimulus zone, and this stimulus with zone, this particular zone predict that this guy will appear here, a smiley face, it will do ooh, like that. So you say beep, ooh, several times. So what happens when you say beep and your guy didn't appear? You say, oh, where is my guy? This is also a violation, and the unexpected generate the response in the frontal lobe for the babies looking for something that I expected not happen. And other two examples, one is the odd belief the infant from 7 months old, so very young babies, can in some way process what other person are believing. We did it with the test in a like theory of mind test, and you have there is an agent here, a person who is believing something, and you, the baby, is watching this series of video stimuli. And in one case, the agent who is being involved in this study is know something about what happened here. For instance, he knows that a ball go behind a screen, a box, inside the box. So, and this box, when this guy go out, it's not present in the scene, this ball can go out and leave or can stay there. So the baby reacts in a different way based on what they believe that the other guys believe. So when the guy is present, when the guy is present, the response, this is a looking time, the looking time is a way to evaluate, to measure if you want, the interest of the baby to a particular stimulus. So when the guy is present, that is an A+, when you have A+, the infant responds with longer gaze, looking time, for true belief and for false belief. When the infant, when the agent is not when the agent is waiting for something that is not true. For instance, the agent believes that the ball is behind the screen, but the ball goes away. The children know that. And the metacognition is also another very nice experiment that recently Steve Quider presented, where they ask for, they say, well, metacognition is a way of consciousness and uncertainty, whatever it is, this uncertainty is something that is inherent of the metacognition. So when you know that you don't know something, the infant, of 20-month-old infant, asks for help. If you train them to ask for help, they say, well, how can I choose this or this? How can I divinate that this, the object is this or here? If you teach them before that they can receive help, they ask for help. They say, when I don't know, I look, in this case, you see that they're here, you say, what happened here? I don't know, so I ask, and then I receive my feedback. So from very early, they can know that they don't know, but they can also ask for help. So what is basic for the consciousness? I think I had to try to show you some study that showed that the brain of the infant is ready anatomically, structurally, functionally, cognitively, and they possess several cognitive abilities that they are more than just the physical reaction to a particular stimuli, but also the action, the manipulation of what they are processing in order to create this global workspace where they can use to interact in the future. So I think sorry, but I told you I was not ready to speak in English, so it was a little bit long, but I just want to show you this other stimulus about time, that no, I think I will stop here. It's just I want to show you my abstract, my summary, that, well, we don't know exactly whether and how consciousness is implemented in the human infant mind. So there are a lot of people working on that. There's some evidence that there are conscious thinking and processing in very young infants, even in preterms. And we can accept, I think, for clinical purpose or for clinical purpose in this period of the history, that we can accept that the conscious could be available from when the human is viable, you say viable, viable, viable. Suena como Biblia. Anyway, yeah, and the infant is ready. The human, maybe some, I think I will say that with no fear, that some of this ability, they are innate, should be innate. But certainly, I didn't show you a lot of study about that, but certainly this innate instinct to manipulate the information with the possibility, with the flexibility in the awareness system, allow to the human mind to receive to be modulated by what happened with the interaction with others. And I think this is something that is it's very clear and it's unique for human and not for other animals. Well, this is the people who work with here. Here is Lucia, one of our best collaborators. So this is my talk.
This might be a more clinical question, but I'm an anesthesiologist, and how do you assess unconsciousness in babies from integrating these things you have shown, or even clinically?
Well,
I'm not, as you can see, a pediatrician, anesthesiologist, so.
Unconsciousness. Well, we don't, well, I think the only experiment, we assume that the baby is unconscious when they're sort of sleeping, And if we say also that when the fetus, we assume that because there are different type of physiological circumstances, they are not exactly awake, yeah, they are not aware what happened. But I think the only study that have shown is the SEED study, the quitter study. So when the stimulus are not, don't go above the perceptual threshold, you say they are unconscious, or they perceive it in a subliminal way or unconscious way. There are not many studies measuring what is unconscious, what is the threshold for the unconscious in more than the studies analyzing the awareness. So awareness is really what we have studied with this babies.
Thank you very much. I sort of have a problem with your view of babies being conscious or unconscious, considering that a lot of studies now point to the fact that consciousness might be a more sort of gradual thing.
Yeah.
That, and especially in this meeting, we've heard altered states of consciousness. So consciousness is not just one thing which is yes or no. So saying that at 24 weeks you are and before that you're not, it sounds to me a little bit sort of premature or I'm not comfortable with it.
Risky, yeah, I agree with you. Absolutely, I agree with you. We don't know, I started this talk telling that we don't know really what is consciousness in infancy. I mean, what exactly is, because we don't have the explicit report of that. So for clinical purpose, we use this limit. But if you, in the future, you say, okay, we have an artificial uterus, or we have a way that to make the baby survive before 24 weeks or 22 weeks, maybe the consciousness can start before. Maybe the consciousness starts when you have the first step of the nervous system. I don't know if I answer you, but I think your concern is my concern too. It's the concern of all the people who are studying consciousness in infants. We are not exactly what we are measuring. We just measure the response that we can evaluate with the electrophysiology or physiology of the body or pupil diameter or something like that. So I agree with you, sorry. The limit should be just for clinical purpose.
Well, when the fetus is in the uterus, it seems to be asleep. In what moment, when you can differentiate REM to non-REM sleep?
Well, in the fetus, well, we don't have there's some study who can say that you have active and non-active. In REM, non-REM doesn't exist in infancy, in infant even, in fetus either. But you can have something like behavioral states that are equivalent to REM and non-REM, that is active sleep or quiet sleep. So roughly it's the same. And active sleep, you have a lot. The infant have really a lot of active sleep in preterm, and also in fetus if you measure with the behavioral parameters, criteria. So if you want, when you are, for instance, some professors, some researchers say that maybe the active sleep is an equivalent to wakefulness. And you have this because you are not ready to develop wakefulness when you are very immature, but you cannot wait, for instance, 6 months or after birth to be awake, to really be awake. So you can do something equivalent that train your system, and this is active sleep. That should be similar to REM sleep. And this you can observe in fetus roughly after 24 weeks.
Do you have muscular atonia during this active sleep?
Sorry?
Do you have the muscular atonia during...
Well, I think where you are right. We don't use all the same criteria to say that this REM sleep or not in a preterm, because so after birth, I agree with you. There are more atonia in active sleep. But in preterm, they have always atonia. The muscle tonus is very, very small, very nothing, it's like blah, and that. So you cannot use this criteria. You use the electrophysiological criteria and remove eye movement. This you have, it's very, very sensitive.
So you see synchronized EEG, so you see
it's not the same. It's not exactly the same. I think the EEG of the neonate is very different to the adults. We don't have exactly the same criteria, but we use pattern of the EEG. In general, the pattern of the EEG is dominated by the slow frequency all the time, even when you are awake in infancy. So they are also slow. They have a tendency to be in a very huge activity on the theta band and delta band. So if you consider inside of this, you can have differentiation with the more burst of higher frequency. So you can differentiate different states, but with this background that is very strong in the low frequency activity. I don't know if this was clear in the thought.
Any other question?
So, if I can say, oh no, yeah, terminamos, no? Yeah, sorry.
We hear today about the Mozart effect. You talk about the fetus can listen the mother voice, the mother voice. What do you think about the Mozart effect?
The Mozart effect? No, the Mozart effect, I think it's not Pedro here, but Pedro can explain you that it was really a bad interpretation of the result. Yeah. It was just a very particular result that was related with only a particular test of the IQ, IQ that is a spatial cognition, and it was really fake. It's not true. Yeah. And nobody, there are many studies that didn't replicate. However, I think the oscillatory nature of the brain activity and the oscillatory nature of the brain activity in infancy is crucial for learning speech, for instance, turn taken, mother-infant turn taken, and if you want alternative synchrony or any synchronic activity that you have with young infants.
But he listened sounds.
Yeah, but wait a minute.
He listens sounds.
Say, for instance, this is what we believe. We believe that speech is predominant in theta band. Yeah. Why? Because syllable is happening in theta band. You have ba, ba, ba. This is independent of your language. Every language has syllable, and the syllable is a sort of pacemaker. And so if the infant listens to the sound, I didn't show you our result, but if the infant listens to this ba, 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 they also resonate with this theta band. So if we have a music, maybe this is not demonstrated, but it's possible that if we can train this sort of theta resonance or entrainment, neural entrainment of this frequency or other frequency with music or with other stimulus, this may help to improve the efficiency of this system. Yeah. Not only to predict, also to detect violation of the prediction.
Yeah, because I think maybe it's a philosophical. Yeah, I think before the brain, we have a heartbeat.
Yeah, that's a good idea. Yeah, this is exactly what we are doing.
Yeah, and the fetus grow in the womb, you listen the heartbeat of the mother too.
Yeah.
Yeah.
Well, we are doing an experiment. I think we can show you. For instance, we compare the preterm and the full term. The full term was 9 months in the womb, and after 25 weeks, they can listen. They have the connection between the cochlea and the cortex. So they have 3 months of experience with the heartbeat. And the preterm not. The preterm is born, And then they receive all this noise that comes from the incubator and blah, blah, blah. And we are studying resonance entrainment, neural entrainment. But I think you are right. Maybe the heartbeat and other type of regular, the voice of the mother that is also have this syllabic, rhythmic stimulation can modify or can train, if you want, can prepare the baby to process what happened later. So I think it's a good idea.
It's beautiful, at least.
Yeah.
Before the brain, we have heart.
So, yeah, thank you.
Thank you so much, Professor.
So, gracias.